So this time we're looking at lesson 2, multiplication of numbers in exponential form. And on these notes, we're going to look at multiplying the same base with a different power. And we have our algebraic rule there. In general, if any x is any number, and m and n are positive integers, so we're looking at x being any number, but what we do see is that it has to be the same value. So same base to a positive integer power, then that is the same as taking x to the m plus n. So basically we're just adding the powers together, or adding the exponents together. So you can see it written out algebraically. X to the m is x to the m times, or times itself m times x to the n is then to the n times, and so we put those together as m plus n, and so we would write that as whatever that sum of m and n would be. So when we're raising the same base, multiplying the same base to a different power, we just add the powers together. And so we look at exercise 1, 14 to the 23rd plus 14 to the 8th. We can write that as 14 to the 23 plus 8, and so that is 14 to the 31st power. And then looking at exercise 2, so that's algebraically, so we have the same base, and we're raising it to a different power, so that's a to the 23rd plus 8, and so that is a to the 31st power. So as long as the base is the same and we're raising it to powers, then we just add those powers together. Looking at exercise 3, notice the negative numbers in parentheses, so it is that negative number, that's the base, and so that's negative 72 to the 10 plus 13, and so that's negative 72 to the 23rd power. Now we could simplify that using a calculator, taking it to the 23rd power and get a simplified answer, but we're really just looking at the exponents right now. And so exercise 4, let f be a number, and so that would be f to the 10 plus 13, and so that is f to the 23rd power. So as we continue, exercise 5, we have negative 3 to the 9th times negative 3 to the 5th. So we're thinking through that, and we want that to be negative 3 to the 9 plus 5. And so that would be negative 3 to the 14th power. Again, notice that the negative number is in parentheses. We need those parentheses when we're taking a negative number to a power. Then the next one, let x be a positive integer of negative 3 to the 9th plus negative 3 to the x is equal to negative 3 to the 14th, then what is x? So we're looking for the value of x there if their sum is 14. So you're thinking through, okay, 9 plus x has to be equal to 14. And you know how to solve this equation. You just subtract 9 from both sides. And so x is equal to 5. What would happen if there were more terms with the same base? We just write an equivalent expression for each problem. As long as we're multiplying the same base, so we have the same base for each one, a base of 9, we just add the exponents together. So that's 9 to the 4th plus 6th plus 13th. And so that is 9 to the 23rd. So we do the same thing for exercise 8. We're just taking, we look and we make sure it's the same base of 2. And so that's 2 to the 3 plus 5 plus 7 plus 9th power. And so that is 2. And so that gives us 2 to the 24th power. So for the next part, we're seeing if we can simplify, but where we have to be careful here is that we're making sure that we're looking at the same bases. So we can combine the 6th to the 5th and the 6th to the 14th. That can be 6 to the 5 plus 14. And then with the same base, we have 4 to the 9th and 4 to the 3rd. So that is 4 to the 9 plus 3. I'll write that over here, 4 to the 9 plus 3. And so we can simplify the whole thing and say, okay, that is 6 to the 19th times 4 to the 12th. And notice that we're only adding the powers to the powers that belong with the same base. And then here for exercise 10, we have 2 to the 4th times 8 to the 2nd. These are not the same base, so we can't just directly add them together because they're not the same base. However, we can write 8 to the 2nd as a power of 2. Okay, where this one is a little bit different is that 8 squared is 64. So thinking through that, and that is 2 to the 6th. So I can rewrite that as a power of 2, or 2 to the 6th. And so this is 2 to the 4th times 2 to the 6th, which would give me 2 to the 4 plus 6, which is 2 to the 10th. So a little extra thought there about how to break down 8 squared, but we get the same idea of adding the powers in the end. For exercise 11, again, we're looking at just making sure that we only add the powers of the same base. So this would be negative 4 to the 2 plus 3, or 5th power, times the 17 to the 5 plus 7, or the 12th power. Then we can't really do anything else with that. We just get that same result because we don't have the same base, and so that's all the further we can go, unless we would use a calculator to figure out the power answers, but we're just writing the answers out right now. All right, so exercise 12 we're looking at again where we don't have the same base, but that number 9 can be thought of in terms of a power of 3. 9 is the same thing as 3 squared. And so we end up with 3 to the 7th times 3 squared. And so that gives us 3 to the 7 plus 2, or 3 to the 9th. All right, then you taking a look at exercise 13, we do not have the same base here. And so that is already simplified. Unless we would use our calculator to find out some other values, there's other ways we could express it, but there's not the same base, and we can't write those in the terms of the same base, so we just let it go. And then for number 14, we're going to break that down and say 2 times 17, so putting our coefficients together, times x to the 3rd times x to the 7th. 2 times 17 is 34. And then x to the 3rd times x to the 7th is x to the 10th.